A very good evening and warm welcome to all the participants. Please join me in requesting and welcoming Shri S Kiran Kumar Garu. Sir, welcome. Thank you very much for agreeing to speak today. We are extremely privileged and honored with your presence. In spite of having a busy schedule, you have given us this commitment to speak in the leadership conversation today. Sir, for your benefit and for the benefit of others, I will mention that we conduct these leadership conversations every Friday evenings, typically, and these are attended by working professionals from across various domains like technology, like science, education, business management, entrepreneurship, sports, social life, so on and so forth. And today, many people are joining us live on Facebook as well as on Zoom to attend your session, sir. And once again, thank you very much. I will make a brief introduction and quickly hand it over back to you for your remarks, sir. So allow me to share the screen.
Okay.
We call it Wise Views, these leadership conversations. This is the 77th 77th week. Okay. We are hosting this. The topic is Space, Technology and Society, Lessons from ISRO. We will be spending about an hour in this. The first 20-25 minutes, Kiran Kumar sir will be sharing his thoughts and perspectives on the topic, followed by Q&A. We'll try and conserve as much time as possible for the question and answer session. A brief introduction of this profile. Shri S Kiran Kumar is Vikram Sarabhai Professor at ISRO, Bangalore, and member of the Space Commission, Government of India. During 2015 to 18, he has served as Secretary, Department of Space and Chairman, ISRO. He has steered the implementation of the applications-oriented Indian space program, which has facilitated rapid development of the country in many important spheres of Earth observation, communication, navigation, meteorology, and space science, as well as the development of indigenous launch vehicles and related technologies for providing assured access to space. He has led design and development of more than 50 electro-optical imaging sensors flown on various spaceborne platforms, starting from Bhaskara in 1979. Further, his role in the success of Chandrayaan-1 mission and Mars Orbiter mission has been significant. Shri Kiran Kumar has been the chair of the Committee on Earth Observation Satellites, CEOs, in 2012. He has made valuable contributions to Coordination Group of Meteorological Satellites, CGMS, Expert Team on Satellite Systems, World Meteorological Organization, and Indo-US Joint Working Group on Civil Space Cooperation. Shri Kiran Kumar is the President, Aeronautical Society of India, and Fellow of Indian National Academy of Engineering, National Academy of Sciences, India, Indian Society of Remote Sensing, Institution of Electronics and Telecommunication Engineers, Indian Society of Systems for Science and Engineering, Indian Meteorological Society, Indian Society of Geomatics, Gujarat Science Academy, Andhra Pradesh Academy of Sciences, and an elected member of International Academy of Astronautics. He has been conferred with honoris causa and DSc by 18 Indian academic institutions. That's pretty impressive, sir. He has co-authored 85 publications in various national, international, scientific journals and conferences and symposiums. That's very, very impressive, sir. We are so honored and blessed to have you today with us, sir. So I would like to thank you for your presence, and I'll take one more minute, sir. In recognition of your contributions made by Sri Kiran Kumar, he was conferred Padma Shri by the President of India in 2014. Other notable honors conferred on him include Rajyotsava Award for 2015, Sir M. Visvesvaraya Senior Scientist State Award for 2013 by Government of Karnataka, Lifetime Achievement Award from Karnataka Science and Technology Academy 2016. He has also been conferred with the prestigious 2018 International Von Karman Wings Award instituted by the Aerospace Historical Society, together with the Graduate Aerospace Laboratories at the California Institute of Technology in 2018. And the Chevalier d'Ordre National de la Légion d'Honneur the highest civilian honor by the government of France in 2019. This is very, very big. Sri Kiran Kumar holds MSc degree in Physics and Electronics from Bangalore University and MTech degree in Physical Engineering from the prestigious IIS Bangalore. Thank you very much, sir. We are really, really happy to have you. I will now stop sharing my screen and I request you to start your remarks. We are all ears and we are waiting to hear from you, sir. Thank you very much, sir.
Thank you. Thank you very much. And at the outset, it's a great privilege to be part of your leadership dialogue discussions. And also thank you for giving me an opportunity to share with all the participants on how India looked at this technology of space and how it has brought in significant results from the use of this technology for society and the country itself. Probably we are all quite familiar that India was a very fledgling democracy just 10 years after independence, when the first object was put into space by Russians way back in 1957. And at that time, really the issue was the two superpowers were really trying to demonstrate who is more powerful and who is more capable. And at that point of time, we had a great visionary scientist in our country, Dr. Vikram Sarabhai, who was looking at, see, how a technology of going to space and then putting objects there and using them, look at from space to Earth and also space to space, how this technology can be used for rapid development of our country. And it is really his great visionary thoughts and processes which has led ISRO to achieve what it has done till today. And in the very initial days, what he did was he brought in this capability of going to space by convincing his friends across various countries like Germany, France, America, Russia, and convinced them that in India we have a unique place near Tumba, Trivandrum, and it's a geomagnetic equator. And if at that place we conduct upper atmospheric research, it will be beneficial for the scientific community. And under that particular approach, he could bring sounding rockets in the form of kits. And those kits got assembled at Tumba and then got launched. And through that process, he could bring in the experiential learning of putting together the launch vehicle and then putting them into the space. And at that time, in fact, there is a very interesting small story. When the first launches had to be done at Tumba, he actually had to convince the fishermen in that place with the help of a priest of a church in that region, and with the help of the priest, he could convince the fishermen that if you vacate this place and allow us to conduct these experiments, one day in future, the country will benefit. Just as though to demonstrate what he had actually told, from 1999 onwards, India was able to provide to the fishermen across our 7,500 kilometer long coastline, specifically where they should go for fishing. And this act alone saves almost more than 10,000 crores a year, because the money saved in petrol and diesel consumption and also the time saved by the fishermen. And to this capability, and how this was done is using the satellites, looking at the color of the ocean, and through the color identify the chlorophyll, and through that look at the food chain of the fish, and then identify where in the ocean one could get these fish schools. And this prospective fishing zone information was being initially disseminated using the pagers and the electronic boards that were available at that time to the fisherman community. But today we have gone much further, and many of you are familiar that we have our own Navi constellation, which is again a very different concept compared to many of the others who are using global positioning system. Americans, GPS, Russian GLONASS, and then European space agencies, Galileo, and Chinese BEIDO. All of them use between 24 to 32 satellite constellation. but we make use of only a 7 satellite constellation and enable India and beyond Indian borders up to 1500 kilometers, an ability to locate ourselves using a small gadget. So today what is being done is a small gadget which is battery operated is fitted into the boat of the fisherman, and using Navic, this gadget is able to locate itself in terms of latitude, longitude, and the messaging service available in the Navic satellite tells about the latitude and longitude of the prospective fishing zone, and a mobile in the hands of the fisherman. The mobile itself does not have any connectivity to the terrestrial tower. As you can imagine, once you get into the ocean, few kilometers away from terrestrial location, you cannot have any connectivity. But the mobile with a Bluetooth or Wi-Fi talks to this gadget fitted in the boat of the fisherman, and an app on the mobile enables the fisherman in the form of a video compass. It points to him where he should go for fishing. Not only that, in his mother tongue, it tells him about weather vagaries that could occur, or even the sea state roughness. If sea state is not going to be unbearable, it gives him alert in his mother tongue, and also alerts him if he is approaching international boundaries. So you can see here in this particular case, a fisherman who does not know reading or writing is actually making use of the most advanced technology of launch vehicles, satellite applications, and then mobiles, and is able to perform his livelihood by catching fish in an assured manner. So this was one of the very important development that happened using space technology. Similarly, what Dr. Sarabhai had envisioned at that point of time, he was looking at how this space technology can be used for rapid development in the country. We can all easily visualize in the mid-70s when the India had only 4 metros had the provision of looking at broadcasting, and places like Bangalore and Hyderabad did not have. At that time, Sarabhai convinced Americans that they should allow us to use one of their most advanced technology satellite, ATSF, and borrow for a year and conduct an experiment where, using this geostationary platform, broadcast in 2,400 remote villages of our country using a technology which today we are familiar called direct to home television with a set-top box and a small antenna on the rooftop. But in 75, this was achieved using a 3-meter antenna, and then using almost half a rack equipment instead of a small set-top box. All this electronics was built in the country, and in 2,400 villages, India ISRO demonstrated to the government that we can make use of the satellite technology and provide information to the people of this country in a rapid manner. Because if at that point of time, if we were to use the technology available of microwave towers every kilometer, not only would it have taken a long time, but also the amount of resources required would have been enormous. And again, the important thing to note is, even the technology was developing, India was the first country to demonstrate to the world that space technology can be used for rapid dissemination of information using this technology. And at that point of time, it was actually the world's largest socio-technological experiment conducted. And this experiment demonstrated to the government that space technology is the way to go for both in broadcasting, communication, and like navigation, I already pointed out. And in this manner, the vision of Dr. Sarabhai of using space technology for enabling the country's growth by providing communication, broadcasting, navigation, and not only that, Earth observation, where using the images collected from the space, where you don't have any state boundaries or national boundaries, you can collect data over the entire globe. And using that data in the initial years, exercises of where we can drill bore wells with almost 90 to 95% success rate, that was done. And today we have got a large fleet of satellites which are providing information about the crop yield forecasting, or in terms of providing information to the strategic requirement, or both in terms of communication, navigation. In navigation, you will also be happy to know that we are providing, apart from Navig, a service called Gagan, where all the aircraft, when they are flying in space, they make use of satellite-based signals and locate themselves more accurately, and also for precision landing, this capability of Gagan is used. And the India has made it mandatory for all aircraft registered in the country beyond 2019 January to carry this. And you also would have read recently in the papers that in our airports, which are at remote places where smaller and smaller airports are there both the Indigo and SpiceJet have landed using these Gagan capability of Navig as well as GPS data. And so in this manner, the country has been provided with a significant capability of from space. While all this was happening, the development required for building the launch vehicle technology, satellite technology, and the instruments and application, all that was built in the country. And in addition to that, enabling the academic community and also the research community a provision for having our own virgin data, whether it is Chandrayaan. Chandrayaan, you can see that when we did in 2008, while man had landed on the moon and a large number of probes had gone around the moon, the Chandrayaan-1 gets the credit for discovering the presence of water molecules and water on moon. And similarly, when the Mars mission was done, it was demonstrated that you could do interplanetary missions in a very compact and cost-effective manner. And recently, when we completed the Mars mission, it had actually served for 8 years, while originally the plan was this we will be able to operate this satellite for a period of 6 months. And also, you will be happy to know that AstroSat has in its capability in a particular region of electromagnetic radiation, a capability which is better than the best telescope in the world, even compared to Hubble or James Webb. In ultraviolet, it has got an angular resolution which is better than 3 times the next best, and a sensitivity. Using this, the researchers in the country are able to get some virgin data and have found some very interesting new things. So in a way, what the country has seen is this disruptive technology of going to space and then putting satellites into the various orbits. Today, the country has a capability, and we are among the few countries which have got this end-to-end capability. And we are now progressing further towards enabling the country to make use of this space technology and to become a player in the global space economy, which is likely to reach almost $1 trillion very shortly. And if India has to become a significant player in this space economy, the not only private enterprise, but also the academia, all of them have to take advantage of the base that has been established. And the government is now trying to bring in new policies and new conditions, which is more conducive for India to take advantage of what development has happened and move forward in this. And that's why you are seeing a host of new policy and changes occurring. And again, another capability today, we are also familiar and seeing that while we built all these capabilities in the country with the shoestring budget that was there, globally things are changing. Space is no longer the domain or operations of only nation states. Large number of private companies have already started doing their own independent space activities. Today, Elon Musk or Jeff Bezos, they have got into space tourism, space adventure, space exploitation, space habitation. So like man started conquering land, ocean, and airspace, now he's looking at getting into space itself as the fourth frontier. So in all this, if India is in a good takeoff platform, it is because of the visions of great people like Sarabhai and consistent effort of both the government and the organization like ISRO to develop in the country a technology of building rockets, building satellites, building, and then not only doing all this, but also demonstrating them using this, finding specific solutions to the problems we are facing and making it relevant for the country. So now the next step is to make it happen in such a way that the economy of space, India becomes a significant player, and in $1 trillion economy, even if you are able to reach 10 to 15% of that economy, it'll be a big boost to Indian economy. And that's how both the country and the organization is looking. And towards this, you will also be happy to know that one of the launches which is going to happen shortly tomorrow is an opportunity which came when the Ukraine-Russia war started. A set of satellites were on a launch pad sitting on a Russian launch vehicle. But then because of the geopolitical situation, this particular set of satellites have been removed from that, and now that is getting launched from our GSLV Mark III, and this is going to happen tomorrow. So there are opportunities, there are changing scenarios, and technology as a development, and the country needs to look at how this space technology can be utilized for bringing in newer ability in playing a role in the economy. So what ISRO has shown is that it is possible for you to do a lot of things in the country, build capabilities, and also remain relevant. And also in some areas, you showcase to the world that you can do applications in a very different manner. So in this manner, the organization has shown, and today we are at a, you can say, a takeoff point where the technological base that existed and has been developed needs to be utilized by the private enterprise, and then academia also needs to do a lot of work, because what is in store, you have to compete with a private enterprise which is both dynamic and is very quick, and then government entities cannot match with them in terms of the speed of decision making or providing the resources. So today, this is where the country stands. And with this background, I'll be more than happy to engage with any questions that come to your mind. Thank you very much. And thank you very much for this opportunity to explain what has happened in the past and where we stand today. Thank you.
Thank you, sir. Thank you very much. As the noise of the crackers is getting shriller, as we are going closer to Diwali, we are sitting down and trying to understand and learn from the journey of ISRO. I think it's a very, very inspiring way you have told us the story that unfolded in the beginning days with the inspiration of Vikram Sarabhai, the visionary scientist, how he has passionately engaged with his friends in India and abroad to build capability back home. I think that's an amazing journey and start, a very, very inspiring beginning for us. In the areas of navigation, in the areas of broadcasting, in the areas of communication, how we subsequently built our strengths from measure to measure, how we built our strengths, I think that is also a very impressive journey. And several milestones that we have covered under various leaders like you, who have been the chairman of ISRO, not only the chairman of ISRO, but also being part of this program, space program throughout. Under your leadership, I think we have seen several milestones. And today, with a lot of pride, we can talk to the world and also tell the youngsters how we can look into space. Looking into future is like looking into space. And that's a fantastic way of building a new opportunity and a sense of pride for us, on which we can write the name of India that we have done and turned around. Wonderful, sir. Thank you very much for this opening note. What we'll do is we will again conserve time, and we will request you to respond to the questions that the audience would have. We have collected some of these questions at the time of registration, and we have landscaped them properly and put in a cluster format. So the first cluster of questions will be taken up by Professor R. Prasad. Professor Prasad, I request you to start the cluster one. A brief introduction to Professor Prasad. He is the Director of Academic Wing at the ICFAI Group headquarters. And he is a BTech from IIT Bombay and PGDM from IIM Kolkata, and has 3 decades of rich experience in entrepreneurship, corporate life, as well as in academics. Over to you, Professor R. Prasad. Please start.
Thank you, Professor Rao. Thank you very much, sir. ISRO is indeed an organization which is revered. I had the honor of doing my summer internship from IIM Calcutta in ISRO.
Okay.
And during those times, there were market studies done. Today, we are talking about economy, space economy, but even during those days, very early 90s, 90 to be precise, I think ISRO was doing market studies and trying to see how to promote it. Very revered organization, sir, and we had the privilege of speaking to many members from ISRO. So with that, I will get into the question cluster, sir. ISRO, we know. The other large space agency that we know about a little bit in detail because of the publicity it receives is NASA. Now, how do you distinguish between these 2 organizations in terms of missions and outcomes, sir?
Yeah, of course, in this comparison, when you're looking at, there are 2 aspects you have to see. NASA itself started its activity much earlier, and they, because of being part of the superpower, and their task initially was to actually demonstrate a capability which is very different. And then they were actually trying to compete with Russia, and then Russia had already put the first object in space, first man in space. So like that, when it was going, it was necessary for America to show that they also have some capability, which is, so that's how the moon mission started. So their task and the way they started the activity was primarily, you can say, military activity starting, and then going from that arena towards various other applications. And if you look at ISRO's activity, primarily, India is the only country where the space activity started not as a military activity, but as a civilian activity. And here, like a technology of space, how technology of space can be used for societal development. That's how, in fact, if you look at Satish Dhawan and people like that who guided initially, their prime objective was to see that this technology of space, today we are all familiar of what disruptive technologies do, but space was such a disruptive technology at that point of time, though the narrative was not in that form. But then how this technology could be used for societal development. So it's a very distinct thing. And again, in America, if you see in terms of resources available for NASA, there was really not a limitation. It was only demonstrating a capability was their requirement. Though they had funds adequate. But whereas India, if I were to tell you all the amount India has spent till now, even after adjusting for the value of money over the years, adds to less than a fraction of 1 year's budget of NASA. So that's the kind of differences in terms of economics. And then again, we being a developing country and the area of space technology itself being dual use, its technology also is not easily accessible. So what ISRO has done is whatever technology is accessible, it has used. What is not available, it has developed. And with the shoestring budget and with this kind of constraints, it has actually done a lot of innovation and provided results. So in many ways, comparing the 2 entities probably is unfair because you are not on an equal footing. But what we can definitely say is because of the limitations and because of the constraint, we also have done many things very differently.
Excellent, sir. In fact, it gives us a background to envision to ourselves in many other sectors where we have very large players with financial muscle competing with us, that there are ways to set priorities and way to make impact when you're faced with a lot of challenges and still capture market share and mind share, which is precisely what ISRO has done.
Yeah.
Thank you, sir. The next query, sir, is about leadership. So ISRO has seen many worthy leaders. I mean, considering the kind of research that ISRO has done, which is far more distinct and impactful than what you traditionally associate with a Government of India organization. What what has made this leadership succeed? I mean, there must have been some common factors. And what has differentiated the different types of leaders that we have seen in ISRO?
Yeah. See, actually, if you look at the from the very beginning, if you see, Dr. Sarabhai himself was one of the phenomenal individuals. So he had a background in so many different areas, diverse areas, and he also came from a very, you can say, a family which had many industries and philosophy, so many things. And he also was at the time of independence, or even during the World War time, he was doing his research outside, and he was in the cosmic ray and one of the most advanced research activities he was doing. So he had a very broad background. But then while his vision was very clear that how technology can be used, but then he actually did not survive to see the fruits of some of the things what it said. Even 75, when the first experiment was conducted, he had passed away in 71 in a very untimely death. But then it was Satish Dhawan who took over and did the initial steering. And much of what ISRO has developed in terms of both culture and in terms of the mechanisms which initially was set up, all we need to give credit to Satish Dhawan, because you can see as an individual also, maybe a couple of points will showcase his approach. See, when Vikram Sarabhai passed away, and when the government was looking at whom to be taken for a leader, then when Madam Indira Gandhi was told that it is Satish Dhawan who should be actually offered this, and Satish Dhawan was at that time in Caltech on a sabbatical. So she called him, and even for that call, he was giving a lecture, and only after the lecture was over, he took the call. And then when he was asked to take over, he said, I want 3 conditions. If these 3 conditions are agreeable, then only I'm ready to do the thing. So one was, I want to complete my sabbatical and come back. And I want to remain in Bangalore, continue as a director of IISc, and the headquarters should be in Bangalore. So these 3 conditions. Now, what it shows is he was a person who had an independent thought process. And then again, he was also, you can see his own background. If you see, both he has done in MA in English, then science, and then he was but then all his capability, he was looking at how this technology can be translated and then brought to actually the community's use. So he actually, you can say, made sure that the programs, even from the very initial stage, was tied up with the user and user community in the communication area or remote sensing area. And then he conducted activities where many of the secretaries were brought together. So that means linking, even at the time of design, the user community was the thing. Then actually conducting very thorough reviews, subjecting the people who are actually running the programs, subjecting them to a review process where reviewers could be coming from across the country, using even academia and people at different levels of hierarchy. And it is this act of exposing the people who are doing the running the project. And here again, 2 things we need to appreciate. While the people who are running the project have the responsibility of delivering in a given time, but all the time they are subject to detailed discussion well beyond whatever their thought processes are. But at the end of those reviews, still the choice of how they are going is left to the managers, because at the end of the day, you have to remember that they are tasked to deliver in a given time. Many times when we ask questions, simulations, etc., we can end up in a, you can say, endless loop of answering questions. But then these people are told that you have to make the best choice given the time and given the thing. So engineering judgments were being made by them, taking into account at that point of time what is the best approach that can be taken, how the choice they make meets the demands of that particular mission, and go ahead. Though that may not be the best choice at that point of time, but it's an adequately safe choice or a good choice. So it is this kind of subjecting them to a review process where they are made to feel that they are not aware of all the nitty-gritties, but at the same time they are given responsibility that you are given the task, you have the choice of making decisions and sticking to time, you go ahead. So these are some of the things. And again, next, another thing is, in any activity, failure is a natural process that occurs. While you are doing things, many failures occur. How you deal with the failures, what is required to be done is more than the individual. The problem that is faced and the problem which resulted in failure needs to be addressed more. So it is these kinds of thought processes which Dr. Satish Dhawan brought in, and the host of people subsequent to that, Professor Rao, Rangan, Nair, Radhakrishnan, all of them followed these basic processes, and then involving academia. And then another important thing is, the indigenization is not to the exclusion of everything. If something is available from multiple sources, please make use of it. What is not available, only you develop indigenously. This is another very important aspect which helped the country make rapid strides. And then treating the industry also as your partner to the extent possible. So these were some of the activities which you can say the leaders imbibed from their seniors and went ahead.
Amazing, sir. I think, we've got far more insight about how leadership functions in ISRO, particularly your narrative on Dr. Satish Dhawan is amazing. The customer orientation of what to talk about in corporate, the user community orientation is there. The reviews, the kind of reviews that you're talking about, and yet giving freedom to the lead managers who are responsible, letting them take their decisions. This is also, I think it is very revealing coming from an organization which is deemed to be in the public sector. This kind of autonomy combined with tough reviews,
Yeah.
I think this is something worth learning, sir. We move to the next question, and this is about the talent that India has. India has amazing talent that from CEOs to technology, a lot of people in the world are using. However, how do we use this talent for India? There's so much there. What are your personal views on this, and what has ISRO been doing? What can ISRO do on this?
This is a very real issue. Talent has never been a problem for the country. The country has tremendous intellectual capability and people with this thing. The real problem has always been providing appropriate infrastructure and building those infrastructure using which the talent can deliver. This has been the problem. And today, if you see, what is also happening is, because of both in terms of the resource constraints and the baggage that we have of the being ruled for a long period from others, and even when the changeover takes place, how quickly the mindset of the colonial rule, and then West being best, and then our own heritage and our own backdrop being actually in some ways denigrated, etc. Coming out of that mindset, these are all the things that have been existing in the past, and coming out of that is where the real issue is. And today, you can say more and more as the situation unfolds, and what country has seen even in the COVID times, the way India managed itself is a tremendous, again, example of how the talent that is available, given the right opportunity and orientation, can deliver and make it look, make it better than even what you are seeing outside. And even the way today digital technology has been adapted for fintech, etc. For a long time, you have been hearing that our software people are doing all that, but it's only they have not brought original products, etc., was being said. But reality is that while that capability is there, they were all actually in many ways providing solutions to those who are setting up infrastructure, and they were benefiting from that. In many ways, in the first industrial revolution, if physical raw material was what was being taken out from the country, and then the finished products were brought back and exploited, many ways, still recently, it is the intellectual capability of this country which was being exploited as the raw material. Again, the infrastructure lies elsewhere and the benefit goes elsewhere. If that has to change, like what is being looked at, how things are being done differently, we need to do. But we have a large actually problem here in the sense what AI, ML, deep learning, and many of these companies are doing. They have got so much of head start. And if we have to overcome that, first thing is we also need to appreciate the problem that we are facing and overcome that. So it is never a problem of talent, but it's a problem of both those who are actually governing and running the thing, appreciating that we can do the things here, providing the necessary support to them and not constraining them. That is both in terms of regulation and in terms of giving freedom. See, many ways, probably the government also realizes, but at the same time, the country has moved very quickly forward in those areas where regulation was limited, where the government was not getting into the business of doing regulation. But then there is a problem to that also. So it's a real challenge. But the talent has never been the problem. It is the providing both the resources and the ability to permit those who have the talent in you can say an enabling atmosphere. Things are looking better, things are moving in the right direction, but we all need to find new solutions and new ways of doing it. I don't think there is any defined possible route which can be said, if such a thing were there, by now we would have been following that already. So we all need to keep engage ourselves and then find new ways of doing. And we are seeing some successes, particularly in fintech itself or digital way, even RuPay or many of these things, UIDA. In all this, what India has shown is it has gone beyond the clutches of global super entities.
Fantastic, sir. I think there's a lot of clarity in what you're laying out in front of us. If I look at the commonality, I still see the word space, the creation of the space. First is in the mind, the mindset space, the identity, the blocks that we have in the mind. And you have very rightly highlighted the issue of infrastructure. I think it may not be money, but if people find opportunity that, yes, I can do something good and I can give outcomes, which I feel very happy with, I think many more people would be there to pursue this sort of a line. And of course, I think getting out of the way is also space. I think the government not being in the way, as you mentioned in the case of regulation, is also some kind of a space which is getting provided. Excellent, sir, for giving us these insights. I now move on to the next question. And this is connected to what you've said about resources. It's an innovation-driven sector, and usually there are trade-offs between costs and outcomes. And for a country like India, certainly this will be there for quite some time to come. So if you keep this in mind, what is the trade-off? I mean, what is normally discussed when you have issues like this coming up? We have seen it in movies regarding space, but what are the real issues which come up, sir? Can you enlighten us on that?
If you look at any technology issue or any activity which has to be performed, you always look at whatever that end result you are trying to achieve. For doing that, various resources, including time, then the money, and then the talent, all of that is always in the backdrop. And then many times you are trying to find a solution or an approach which may or may not have already been done. In those cases where you know something has been done by somebody else, then you have one sort of confidence there that it is doable. Others have done it, so we can also do. But then the task will be, challenge will be, you have to do in an environment and with a constraint which is different from what others have done and demonstrated. Because when others have done it, their task is to perform the end result, not constrained by resources. So they will probably be getting all the resources. But when we are doing, in many cases, you always have this problem. And that is where it's a constant tussle. And many times it's actually the ingenuity of each of the small subgroups in delivering what they do. So here, some of the attempts that have been done is setting aggressive targets. That means though many times you know that it is not achievable at the time what you are telling everybody that I want to achieve it at this time frame. So many times what happens is setting such aggressive targets also helps in actually overcoming many limitations, because all of us would have also heard that work expands to fill the time available. So that kind of statement. So in which case, it's always seen that if you have set very aggressive targets, though each one of us may be knowing that it's an unlikely success path, etc. But still, if you keep hammering that, the work starts happening at a pace because everybody starts putting their best efforts. They'll go beyond their limits and then move ahead. So, in that manner, trying to make use of whatever resources you have to the best of the capability and time limits in that's one of the approaches that what ISRO has been taking, and by and large it has been succeeding, though with respect to original timelines sometimes it could have been much later, but then by and large that's the way it has been able to progress.
Thank you, sir. I think there's a wonderful insight and a method for many of us to use in the right context when you mentioned about setting of aggressive targets. The next query, sir, is a couple of days back, the PM launched the mission Space, Defense and Space for innovative solutions related to national security. Space diplomacy is also playing a very important role. And the private sector is also, it is said that the private sector has a role to play. Now, can you outline the scope for the private sector, what it was previously, and what this new mission also adds on to, sir, for the understanding of the audience?
Yeah. See, if you look at in the initial period of space activities, all space activities were done only by nation states, both because that what happens in space, liability with respect to the activities of space, and also in terms of both the money involved, risks involved, it was only the governments which could bring in the resources and do this activity. But then, like in any other activity which human beings are involved, see, if you see human beings started conquering land, then ocean, then airspace, all of that is actually run by private enterprise much more than states. States are actually doing, you can say in a way, protecting the regions, or actually controlling a specific area and in that fashion doing the thing. But space itself initially, because it was not defined to any one nation's boundary, space was actually provided as a common heritage of humanity. The United Nations also came up with its own treaties, etc. on that. But then, as the technology started developing and moving forward, the many in the Western countries, the development and R&D also happened. A lot of that happened in the industry. That was because the wars, world wars, etc., all the war industry is supported by government funding, but the R&D itself happens in industry and academia to such an extent that all these countries spend decades of money. They have spent trillions of dollars in both the industry and academia. Whereas in our own country, if you look at both because of the lack of resources and also the way the country grew the initial period and then opening up the way it happened and all that, the amount of money spent in the industry by the government, etc., was limited. So ISRO also what it was trying to do, because of its limited manpower, etc., and many activities have to be done through industry, it was making use of the industry, and it was developing, taking its industry as a partner doing, because for our own launch vehicle and other things, if you see, we are actually involved with more than 800 companies. They have all participated in these programs and developed. But then these industries by themselves are not in a position to do actually earn out of this activity because of two reasons. One is numbers were small. See, even launches, if you take initially, we started with once in a few years, then a few launches a year. And by the time we reached maybe 8 to 10 launches a year, the whole process of both the COVID and then the space economy getting into private enterprise started changing the thought process of the government. So today, if you look at what government is seeing, that many activities which the space is providing, there are commercial opportunities. All communication, if you see, you are seeing companies setting up their own in geostationary communication, it started much earlier. LEO communication now, whether it is Starlinks of Elon Musk or OneWeb, etc., they've started building a huge constellation of satellites. So there is an opportunity for private enterprise to make use of the space for both earning as well as doing new business. See, like today's space tourism, space adventure, people who can afford can actually go and live in space for very soon. You will already a lot of activities are going on. Those who want to experience few minutes of zero gravity, they're paying maybe 100K or something like that dollars, and then for few minutes they will experience zero G in a parabolic flight. So today, if you see, space provides opportunity for tourism, adventure, habitation, and then exploitation, even asteroid mining. So in all these areas, there is an opportunity, and more private enterprise is getting into that. So in India also, the government is trying to make sure that the technology and access to the facilities that have been established is available to the industry and the people, and they take up and do more. India, for ISRO, for example, recently contracted HAL and L&T consortium for PSLV stage making, and then you are already seeing that there are companies like Agdicool, Skyrocket, etc., building launch vehicles, and there is a company in Ahmedabad which has set up a satellite manufacturing facility. So like that, it is growing. So now the task for us is, both government and ISRO, in space also it has come, is to enable the country to take advantage of the base that has been set up. India is among the few countries which has end-to-end space capability. How this can be actually in a way monetized, and then India becomes a significant player in space economy of $1 trillion in the coming decades, is the real task. So we are all working towards that, and then every one of us have to find actually new ways of dealing. I mean, keep whatever has happened in the past aside, find new ways of dealing with things and come out with solutions.
Thank you, sir. Very happy to know about the evolution, the progress, and the openness to new ways of dealing. Thank you very much, sir. I have a couple of more questions, but I'll pause at this stage and return it back to Professor Rao.
Thank you. Thank you very much, sir. Your responses have been pretty comprehensive and very interesting, I'm sure, for all the members in the audience as well. I will take a couple of questions now, but I request the audience to raise their hand in case they would like to talk to the scientists directly. It is a great opportunity to all of you to engage with sir directly. So you please raise your hands, and I will stop in between whenever you raise your hand, and I will connect you on the screen to speak to sir. In the meantime, I will take one question. Sir, is it true that SpaceX is actually launching satellites cheaper than that by ISRO? If true, what are the reasons, and how does ISRO seek to address this?
Yeah, see, the prime thing here is, this is where the dynamism and the ability of a private enterprise to do things comes into picture. And what primarily SpaceX has done and demonstrated is reusability. That means if you have a launch vehicle, and if you deliver and come back and then take again another set of cargo and then go. So like aircraft, suppose you are told that you can do only one flight in an aircraft. Would it be available? Means, could we have traveled the way we are traveling today? Obviously not. So same way, today, what SpaceX has done is, it has made launches reusable, and then they are bringing in the stage back and landing it precisely at both on land, on ocean, using whether it is rafts, etc., or barges, and like that anywhere they can land back. So by doing this, they are bringing, that is one. And another thing they have done is using a large number of cluster engines, and then using these engines as a combination, and even bringing in the testability itself right at the assembly at the launch pad. So a lot of innovative things that he has brought into practice. And because of that, he is making a significant impact. And then he's also looking, he's the one who is looking at making humans an interplanetary species. So he has a lot of, and of course, all of this he could do because he had built a deep pocket in an activity which was very different from space. probably he also, after the first 4 or 5 failures, maybe he would have stopped if the next one had failed. But then he had that deep pocket, and then once he overcome that, he can go. But point is that if you can make the activity reusable and reduce the cost of that, then that is the real way. And in our own launch vehicles, our first stages, etc., are actually solid motors. And even if that first stage we bring back, what remains is only the casing, physical casing. But if we have that engines, liquid engines, then that can be refueled and then used again. So there are differences. But then these are the activities which ISRO is also going to take up. Now, for example, Agnikul is coming with a 3D printed engine. In fact, this is a very good development. If 3D printed engine can be done, both in terms of testing and realizability of engine becomes very quick. And if that can be clustered and used and then brought back reusable, there is a path for overcoming even others. So these are mechanisms. SpaceX definitely has made the whole space activity very dynamic and competitive. And today, it is just like I said, it is not just the nation states which are there. The private enterprise is moving very fast.
Amazing, sir. Like I said, your responses are so sharp and very comprehensive at the same time. You have identified 4 to 5 very important points that distinguishes SpaceX from what traditionally the space program has been addressed. That dynamism that is brought in by a private player like SpaceX is pretty impressive, and there are lessons for all of us to learn. And you have very specifically identified the reusability, testing, and also deep pockets is one more issue. I think the resource will definitely, whether it is a nation state or a private player, which is extremely important for them to launch themselves successfully and pursue that path till new ways and methods are identified to reduce the cost. Thank you very much, sir. I will now request Lavanya, who wanted to ask you a question directly. Over to you, Lavanya.
Good evening, sir.
Yeah, good evening.
And thanks a lot for the wonderful talk. My question was, are GSLV or PSLV more relevant from the viewpoint of common man?
Okay, so if you were to look at that, see what ISRO has demonstrated, that use of space technology, a technology of going to space, putting objects in space, and then using them, what solutions are provided to the common man. Right from mid 70s and 80s, etc. If you look at, India showed to the world that you can bring in broadcasting in a very rapid way. And if you look between 80s and 90s and mid 90s, what India showed is rapid communication. Probably you also, if you speak to some of the elders, would have told you that if somebody were to talk to another person few hundred kilometers away, they had to go to a central telegraph office and talk to them. And then the space technology enabled rapid the communication development, broadcasting. And if in broadcasting, if we were to use the terrestrial technologies, not only would it have taken more resources and money, it would also have taken a lot of time. It was only with the use of space technology for communication, broadcasting, and even in weather. One of the points I did not touch in the initial thing was, today, if you look at cyclones, super cyclones used to result in loss of tens of thousands of people in our coastal region. But with the space technology, India is actually shown in the past decade itself that super cyclone time also, loss of life is reduced to a single digit number. That is because you are able to tell days in advance, both in terms of the specific location and a time at which the event occurs, and disaster relief agencies are able to actually evacuate people and save. And in terms of navigation, like fishermen, and even in terms of information being provided, whether it is for crop assessment or developmental activity, in the entire thing, what India has demonstrated is, with its own capability of launch vehicle and satellites and this technology, and like I said, also in the amount of money spent, with that kind of a frugal spending, what it produced and provided is a phenomenal result. Though the world over, people recognize that if a country has put the use of space technology for the benefit of common man, India has done it much more visible manner than anybody else. That's what it has shown. So our own launch vehicle, etc., while we have developed, if what we have developed is in the midst of denial of technology, denial of many of the critical components, and today you can be proud you are among the few countries in the world which have end-to-end. And as India actually aims to reach its true position in the Committee of Nations, a country like ours definitely cannot be satisfied with remaining nth place in any of the activities. So if you have to do that, it is your technological capability that matters. And if that has to happen, it's only when you start building this. See, today, not only space technology, we also have to look at technologies of artificial intelligence, machine learning, and bringing all that into application. So in all the technology areas also, we need to bring in. So our ability to build launch vehicle, the another very important aspect you need to remember is people recognize you and are ready to work with you only when you demonstrate a capability, not when you simply claim that you have. So a demonstrated capability is what is needed, and that is when actually people really, the example is our own case. We took the satellite from Americans in 75 for demonstrating the applicability of the broadcasting. So later, they were never willing to do have a common mission. But today you will be happy to know that India and ISRO and NASA and India and US are working on a program called NISA, where this technology of synthetic aperture radar, one of the most advanced technology, which enables you to monitor millimeter level surface deformation of the Earth's surface, which can become an extremely good backdrop for future earthquake prediction and a lot of other activities. So in this project, $0.9 billion is what America is spending, 0.1 is what we are spending. But together we'll be providing this data to the global community, and it is our launch vehicle and our satellite, and we are also working with them for that payload development. So we are among the, in some ways, the equal partners in this kind of activity. So unless you develop capability, nobody is going to see you in the same light. So if you look at these launch vehicles, it was actually a necessity to build and showcase that you have that ability to deal with new technologies, particularly in this dual use area.
Thank you, lot, sir.
Thank you very much.
Thank you.
I request Mr. Sanjay to come in, but at the same time, I want to acknowledge the presence of several leaders who have joined this session. I welcome Professor Mahendra Reddy, and I welcome all other academic leaders who joined from various cities. Thank you. Mr. Sanjay, please raise your question.
Thank you, Sudhakar and Team ICFAI. A wonderful session. Dr. Kiran, we have met way back in the early 2000s in Bangalore, when I actually met you for a tie-up for Antrix marketing of technologies. And also later on when you helped me locate my batchmate who actually was involved at BEL in setting up the Rajesh Khanna, if you remember, sir.
Right.
I'm Sanjay Gadale, IIT Delhi 82, and also I am Bangalore later on. That's where we met up, in fact, at one of your presentations. There are two parts in my question, sir. One was, I think the young lady who asked previously was looking at the use cases between a polar and a geostationary satellite. What is the difference between the two, and how do the youngsters look at opportunities in skilling as well as mastering those particular areas, and what are those areas and who are those particular people who could actually provide those sort of skills for them to look at opportunities in this emerging sector, which is going to be a very huge sector. Maybe that's the first part of the question. The second is a little bit of a query from my basic physics, which I have yet been able to crack, in the sense, when I look at liquid fuel and solid fuels, what is the decision point for choosing between liquid and solid when I mean, what are the technical parameters? Is it weight versus thrust, or is it ignition and the combustibility, which actually defines which fuel goes into which particular satellite launch vehicle? And of course, the last part is again linked to the first one, sir, that if any of the youngsters are looking at opportunities to work in this space, in the space where right from the point of view of the incoming value chain to actually the production, technology, maturation, as well as addressing the markets which are emerging across the world in marketing, like what I was interacting with you on Antrix, where do they look for that information, and how do they enable themselves to be able to make themselves competent for those opportunities? Thank you very much, sir.
Okay, I'll start with your first question on the solid and liquid thing. See, primarily here what happens is solid motors, one of the disadvantages of that is once you ignite, then until its completion, you cannot do anything. So you cannot restart the thing. So one of the limitations of solid motors will be starting it, stopping in between and starting again. That kind of thing is not possible. So once you start, that complete thing has to be done. And then here, in terms of the rate at which the burning happens, and then the like what you're talking about, what thrust it delivers, etc. There are large number of design parameters in that which take place. And then the other advantage is it is in some ways also little more simpler, because once it starts firing, you can be rest assured that it will complete its job till this thing is over. Now, in terms of a liquid, the advantage you get there is the liquid, when you are converting it into its gaseous form, bringing it to engine, and then having the combustion, by stopping the flow, you can also stop and restart. So many times we need to do the stopping and restarting. So that capability comes. Then other thing also is liquid things. It also gives you in terms of the performance parameters also, it gives you advantages, particularly when you go to cryogenic fluids like liquid oxygen and hydrogen, or even in other cases, liquid oxygen plus other liquids when it is done. So it has got its advantage. But then it also has many more complications, because you have to make sure that the right mix of these gases, you convert the liquid into gaseous form and then bring them to the right pressures, and then bring it to the engine, and then at right pressures you can combine them. So it also has large number of difficulties in that. But primarily it is with respect to starting and restarting, and in terms of simplicity of the whole process. Once you start, you can be assured that that particular solid motor, all activities will be completed. So that is on the solid and liquid related thing. Now coming to the question of when, I mean, between GSLV and PSLV, if you look at basically geostationary satellite launch vehicle, by its very name, you are looking at putting objects into a geostationary orbit. And typically these launch vehicles can put the satellite into a transfer orbit. We call it a transfer orbit, where the perigee is in the range of 150 to 200 kilometers, and apogee is in the range of 36,000 kilometers. So that when you are at the apogee, you can make use of the satellite's capability and circularize the orbit. And even in PSLV also, we have done a lot of satellites going into GSL, means geostationary orbit, or even to lunar orbit or Mars orbit. But then the capability is limited in terms of what weight class and what velocity you can achieve. So total velocity, what you can impart to the object, and what mass you can carry. In PSLV, we can do typically about 2 tons of mass to about 1,000 kilometers orbit is what we can do. But in GSLV, today in terms of geostationary transfer orbit, we can do up to 4 tons and almost up to 8 tons for LEO orbits. Using GSLV Mark III tomorrow, when the launch is taking place of 36 150 kg satellites being put together, that it can carry much more than 4 tons to lower Earth orbit. So that is in terms of the vehicle's capability. But then coming to your question in terms of the next generation, what they can do. See, today in the country, there are already companies which have started doing both the launch vehicle, like I said, Agnicool, Rocketeers, and then there are many others, Skyrocket, and there are quite a few of them which they have started developing an independent launch vehicle program, and they expect to achieve success in the coming years. And that's on the launch vehicle side. And they're also addressing, like I was telling, Agnicool has also been able to actually develop a 3D printed engine. So you can imagine that today a liquid engine system has many hundreds or even maybe even 1,000 parts. And if all parts are independently fabricated, assembled, tested, you take a lot of time. By doing a 3D printing, you have reduced significantly the time of both realization. So you can rapidly develop and then assemble your launch vehicle and put. See, today, like you are seeing already, SpaceX is doing every few days a launch, that kind of thing. So they have brought it. So the capability to do very quick launches comes with newer technologies being brought in, reusability being brought in. And the prime thing for any person or a young person is, one is acquiring knowledge and skills in a particular area. For that, what is to be done? But the target they have to set for themselves first is, do they want to actually become an entrepreneur whose idea is to produce the product, market it and sell it, or he wants to achieve a skill in a particular domain, and in that domain he wants to build his expertise. So that is where the choice has to be made, and it's not an easy choice. Obviously, how quickly things change today, the cycles are being shrinking. See, earlier, for example, the one program would have taken 10 years and then your next vehicle would come out. But today, people are trying to do it in a shorter and shorter time scales. The things are becoming more and more challenging. I don't think I have a clear answer to tell that if a youngster wants to do this, he can follow this path. It's really a very challenging thing.
Great.
So what I can suggest is, definitely the way things are changing in this world, it's their ability to look at problems and finding solutions to the problems. If they learn that process, they'll be able to do it in any field. That's what I would say.
Thank you, sir. Thank you very much for that very large, comprehensive answer yet again. 3 questions into one. But the takeaway is that for the youngsters, for the next gen, there is a lot of space if they learn to solve problems. Yeah. I think that's fantastic. I'll now invite Professor Samyadeep Chakravarti, who is joining in from Kolkata, to ask his question. Over to you, Professor.
Good evening, Dr. Kiran Kumar. Yeah, it's really my privilege to hear you, because being a space technology enthusiast, I was following it since my engineering days. I have one question. The question is linked with green and sustainable space tech. The question is, on one hand, India and the global nations are moving towards carbon neutral situation by 2030 or 2040, and we are doing away with our natural fuels. And on the other side, no matter how much we are progressing with technology, but space tech still consume a lot of fossil fuels, or carbon emissions are very high. So what are the sustainability or green measures which may be the norm in the years to come for ISRO or space tech overall across the globe? I'm interested to know, sir. Thank you.
Yeah, see here again, one of the key things that we need to look at is, first question will be ability to do something. When you are trying to do ability to perform something, at that time, you are not going to too much worry about all the aspects. Say, for example, when Americans wanted to put a man on, or a space shuttle when they were building, they were not looking at all the, like today, whether it is cost effective or you can build with that, etc. First thing is to make it happen, go into space, have it orbiting, and then put man there, bring back, etc. So same way today, if you look at space technology, it evolved in this manner with what is available, it has done. But then as you start developing these technologies, the contemporary things of how it is impacting, etc., is coming into picture. So today, if you look at liquid oxygen and liquid hydrogen based fuel, so that is a completely neutral thing. So it's a green system. But then whether the entire activity right from starting can be done with that, or that is where many of the things, even picking up oxygen on the way and doing, etc., that starts coming into picture. So effort is on to make it both sustainable and also making use of green technology. But then these all will find traction when the cost of, I don't think I need to explain this, because until the cost of doing something becomes actually viable, that particular technology or that particular capability will not become widely used. See, if it is a few things once in a while, etc., people will not bother about it, but still go for doing. But then today, as we are seeing, as Earth itself, if energy requirements has to be supported with solar power actually being utilized from space and then brought back, the cost of taking things to space becomes important. And then if cost of taking things to space has to be reduced, then again, with the current impact of climate change and all that, becoming using more and more green fuel and then making them cost effective gains ground. But then we will also be looking at in space, when we today we have reached maybe 30 to 40 kilometers per second velocity. But for doing any meaningful travel, interplanetary, etc., you need maybe hundreds of kilometers per second or thousands of kilometers per second. So you need to find new technologies for doing that. So whatever technology provides solution to that will be taken. And then also looking at whether we can get the raw material required from space itself. So there are two parts to this. In those areas where you are going to do repetitive activities, people will worry about bringing in green fuel and then making use of it and making it cost effective. They will work on that and bring it. But there will be areas where you want to demonstrate and you want to achieve a certain capability. In those areas, definitely this will not be a top priority.
Thank you, sir. Thank you. A small sub addition to this question, if I'm allowed, Sudhakar sir.
Yeah, yes.
Just a small addition. The one question is today in the news, it is telling that Chandrayaan 3 is going to be coming up in the couple of years' time. And before that, the abort missions will be checked for. So just curious to know, sir, actually, what are the abort missions and what are those things actually about? Just in a nutshell, if you can give some ideas.
Yeah, see, this abort mission is not about Chandrayaan. It's about actually our Gaganyaan. That means where the humans have to be taken into the orbit and brought back. So the abort mission is, see, at the time of initial launch phase, if some contingency occurs, you need to have a safe bringing back of the Gaganauts or astronauts. So these abort missions are planned such that initially with a takeoff, there'll be these capsules, crew capsules will be ejected and that will be safely brought back. So that also needs to be demonstrated. So that is that abort mission one is talking about. We also had already an attempt that was done a couple of years back, and also crew module recovery, etc. So these are, because once you are putting a human into space, you definitely need to make sure that all the activities you are doing have been tried out, demonstrated, and they are going to succeed with a high degree of reliability. So the abort mission that one is talking about is related to that.
Thanks a lot, sir. Thanks a lot. It's really enlightening.
Thank you. Thank you. Sir, the next question that I would like to ask you, and then we'll quickly close after this because we have crossed the 1 hour time that we have sought from you. You've been so patient and answering all the questions comprehensively. Sir, the question now is about how does ISRO collaborate with the higher education institutions, and what can and what should ICFAI, institution like ICFAI do?
See, today, in terms of engaging with the higher, means various academic systems, etc. See, in the recent past, many things have been brought out. Large number of topics have been identified, and in those topics, an opportunity was given to any institute who is ready to actually take up that topic, do their research on that, and then collaborate with ISRO, both in terms of bringing in both research knowledge, what is available, and doing that activity. So that was one. Many areas were identified and that was done. This is an activity which will be probably repeated at some regular intervals. Other than that, there are also a number of under respond program and capacity building program office. If you look at there in the website, there are a host of things which are identified in that, and academic institutions can tie up and then do this activity. Probably there are also some specific timelines. Some of them, this cycle might have been over, but then in next cycle it could come. And then again, this human space program, if you look at the total capacity in the country is a huge one, and academic institution support and participation will be needed in many areas. And also even if I, for example, like somebody was pointing out earlier, in terms of assessment of what the technology has done, whether it is social, socio-technological. So even conducting such assessment and coming out with evaluation of what it has done will also be a useful activity. There are many possibilities, but for this, best way is to engage with the capacity build. We have in ISRO a specific program office has been established. It's called Capacity Building Program Office, and this capacity building program is not only for building capacity within the organization, but also building capacity outside the organization for facilitating space technology to be utilized in the country. So both academic institution, this is the prime, the task. Now, how a particular task actually plays out depends on a lot of things, both the way academia and its team works. So there are I think my suggestion would be interact with the CBPO directorate, and then you will be able to definitely come up with specific program.
Great, thank you. Thanks for your suggestion. We will interact with the capability building program office directorate, and we'll take it up from there. But the message is that there are lots of opportunities to collaborate and tie up and work together with ISRO. So thanks very much on that. I will ask one question, and after that I'll request if Professor Prasad has got anything, and then we'll wrap it up. Okay. So this question is, when is ISRO sending an astronaut to the ISS, International Space Station?
Okay, see, today per se, there is no specific plan of India doing anything with ISS. India currently has a plan of its own astronaut or Gaganaut being taken to orbit and brought back. And obviously, human space program is not likely a one-time event, etc. So it's a gradual build-up of capability of space station and other things. But here again, the key thing will be the economic capability or economic strength of the country. It's only when the economic strength keeps increasing that the government also will be able to do more and more in all these areas. And also, if you look at in terms of what the government is spending on the space activity, it's almost the same fraction right from the early days till now. Only because the economic strength is improving, that amount is increasing. But there is no significant change in the percentage, whether it is of GDP or whether it is of budget, etc. If you look at, it's almost similar.
We hope that economically we become much stronger, and that fraction that improves.
No, but now more than that, the private enterprise is supposed to do that and then take the country, so that the government also needs to spend on non-commercial activities. It will have the option of doing. So that's where probably we need to see.
Fantastic. Okay, sir. Thank you very much. Professor Prasad, would you have any quick question?
I think broadly the most important ones have already been discussed. So
right. Thank you. Thank you very much. Sir, this session has been extremely interesting. You have been a learner's delight. I mean, the way you articulate and the way you very simply explain everything to us, we sit down and listen to you. I mean, that's been your particular style. With each leader at ISRO, with each chairperson at ISRO, there has been a particular the style of leadership. The visionary leadership that started with Vikram Sarabhai to Satish Dhawan in terms of creating a culture template, which you so passionately explained to us, which we would have not known otherwise. The methodologies and the approach and the culture setting that has happened in terms of the rigor of reviews, giving the independence to the manager to decide about the mission based on the deliverables, only after a threadbare discussion. I think these are lessons that we all learn in our corporate life. These are applicable everywhere. I think what is seemingly a government organization, generally, there are many government organizations where we don't focus much. The private and the corporate will have to learn a lot from the journey of ISRO. So similarly, a leadership style like yours, which is very, very unassuming and very simple, and you make us listen to you in a manner way. I recall the convocation address that you delivered at the ICFAI University, Raipur recently, and how the Honorable Governor was quite impressed. That is still fresh in my mind. So for a large number of students in a public space or a well-organized online conversation like this, or probably we should sit down with you in a classroom, we will enjoy any situation in a conversation with you. That's what is my takeaway here. So thank you very much for that, sir. The several lessons that you have given us, we have jotted down, and we are going to attempt a summary. And very importantly, you have touched upon the talent and how to harness talent by creating an enabling environment, and how to actually successfully trade off between the cost and outcome by posting very aggressive targets. That also, if it becomes a culture of the organization, then you'll overcome several resource limitations. That's a very, very interesting input and also opportunities that we have. While explaining everything, you have created a template for us to look at how private players can actually find their own space or opportunities in space. Private players are increasingly showing interest in India as well. They're coming forward now. So I think the policy of the government is also become an enabler. The other thing that you talked about is, this is going to stay with us for a very long time to come, is don't just claim your capability, but demonstrate your capability. In order to make not just a technology successful, in fact, in order to make any venture, any idea or any business to lead to success, you have to move from claiming to demonstrating your track record, capability, or the success. Then it will have a long-lasting success. That's a very, very important thing for us to take away. And for the youngsters and the next generation, you said there are several opportunities to collaborate and work on, and it is important to even identify areas which are in the sustainability area, green areas which are actually virgin to collaborate and explore. And institutions of higher education can collaborate with ISRO for R&D, for various other pipeline projects, for capacity building and all. I think you have given us a way how to work on that. And also a very important measure in operational success that you have identified and helped us to understand in this very short discussion is how a technology, if it is viable only to be used across for wider application, cost-wise, then only it will find its success or usability to society in a large way. I think we need to innovate constantly to reduce the cost and make sure that we achieve our mission and objective with wider application to society. In all, sir, I think this has been a fantastic conversation. Lessons for all of us. We are from various domains like education, somebody's from technology, somebody's from science, IT, sports, and various other domains that we have, pharmaceuticals. I think everyone has found their answers. They can go back and apply in their work. They can go back and apply in actually building their own enterprises. And I think this session would bring us back to you. Whenever there is a next opportunity to interact with you, I will write to you and seek your time. And I'm sure everyone who is around here, along with me, the entire organization at ICFAI, thanks you for your time in space. Thank you very much, sir.
Thank you. Thank you very much for the opportunity. It's always a pleasure to interact and share with the thing. Just one point I just wanted to make.
Yes, sir.
See, one of the things that we need to actually showcase to the student community today, etc., is the real issue that the country is facing in terms of the challenges. To many times, we have become willful acceptors of the domination that is happening from various entities. And what are those challenges? Challenges of AI and thing, which has actually invaded in many fields of our activity. I think we need to bring to the knowledge of the student community and the next generation this issue and where India stands and how, for example, the China has dealt with this issue very differently. Though it's a very different aspect, but today we definitely need to make sure that our next generation is aware of the kind of thing that is happening in use of artificial intelligence and machine learning activity and how the entire humanity is being converted into a prosumer.
Yes, sir. Certainly. Certainly, we take that point, and I think it is our bounden duty to sensitize and alert the next gen to these challenges. And we keep intervening and we keep having this dialogue where there is value addition, not only value addition, but there is scope for improvement for both all the parties that are involved in this conversation. Thank you very much, sir. So I once again, I can't thank you enough for your time, but humble, grateful measure from ICFAI. Thank you so much, sir. So ladies and gentlemen, that was a wonderful conversation with Dr. S Kiran Kumar, the former chairperson of ISRO. Next week, again, on this time, we are going to take it on Saturday, just as an exception. Saturday evening, we will meet at 6:30 p.m. with yet another leader, Mr. R.V. Sridhar, who is the Executive Director of ArcelorMittal Nippon Steel India. We are going to have a very interesting conversation on turnaround strategies and how leadership can learn lessons from those turnaround cases. So we will see you on 29th of October at 6:30 p.m. and we'll share the communication with you to register. Till then, have a blast, be safe, and enjoy your Diwali. May it have a sparkling and happy impact on all of you, at your family as well as around you. Thank you all. See you next week.